This is the presentation for the Master Design Project. My name is Mauricio Muñoz, and I will give you as much information as possible about the setting of the project that is executed during the second year of the IEM Master program. And this presentation is part of the information meeting that should happen in May 2020. If you have any questions, of course, feel free to contact me via imdesignproject@rug.nl. The presentation in general will include information about the objectives, will include information about the general setting, and some examples, of course, of successful projects from the past. And let's start. What are the objectives of the project? Well, in general, we should carry on a problem. We should try to solve some sort of complex problem where stakeholders are included, where there are some sort of desires of stakeholders, desires that you can translate into technical requirements. Then there should be a sort of clear design or research objective in the context of the aforementioned problem to be solved. And again, so there should be some sort of design methodology. So what sort of methods are you going to use to actually reach the objective? What sort of methods are you going to use to answer your design questions? And eventually to solve completely or partially the problem to be solved. Scientific literature should be included even from the very beginning, even from the proposal part. I'll talk about that later on. Now, this plan should include technical aspects, non-technical issues and requirements, and of course, the project should include the socio-technical aspect. So what's the meaning of the socio-technical aspect? So when designing an artifact that eventually solves the problem, or at least shows a path on how to solve the problem, you should take into account that the artifact is part of a higher context, and a context where operators, managers, technicians, they will eventually use it, or they will be eventually affected by it. Now, this is part, of course, of in general, we would like you to deliver an artifact and also to reflect on how to validate this artifact is one of the important parts that should be discussed during the proposal. In general, the project is part, of course, of an industrial environment. It's not only about being part of a bigger organization or industry. It's also trying to put some knowledge in order to actually solve the complex problem. What I mean is to apply this acquired knowledge during your degree program and to try to reach a satisfactory solution. Now, we need to handle complexity, and again, I'll come back to this later on. So these are mostly the objectives of the Master Design Project. So essentially, you will solve a problem, and essentially this problem should be part of a context, of an organizational or part of an industry context. And in principle, you should make use of academic tools to actually reach such an artifact that will address such a complex issue. Okay, what is a good master design project? Well, if you take into account most of the aforementioned objectives, then actually a good project is the one that achieves the objectives that I just described. And these are in principle 5 different elements to be considered. And I'll talk about those 5 elements. So what is not actually a good master design project? When there is actually no clear problem definition. And this is one of the main issues we always address at the very beginning. Of course, there are talks that you have with your potential first supervisors in the industry. You got interviews, you got technical information, and you try to build a story with not only the problem, but also the business, your system, what's going to be the artifact. And in general, those elements are not clear from the very beginning. And given that fact, it means that we are not in the right path to have actually a master design project, not even a proposal, approved proposal. When the project is only about implementation, when it's only about putting into work or making work some sort of technology or algorithm that already exists, then we hesitate a little bit about it. There should be a clear design. Here we can actually reach a gray zone where yes, it's a project about implementation, but there should be a sort of clear design towards reaching the implementation. So what I mean is that it's not always black and white, the situation with the master design project. So, but when it's clearly only implementation, then we may have an issue. It's common to work actually with managerial issues as an industrial engineering and management. And when it's about changes in the organization, and when it's about making the organization more flexible or redesigning the hierarchy or tasks, that deviates sometimes too much from the Faculty of Science and Engineering. And it actually reaches more or is closer to a project that is coming from the Faculty of Economics and Business. And there is nothing wrong with that. But we need to see the scientific effect, the engineering effect. Yes, it can be a change of the management, but okay, let's use game theory, let's use graph theory, let's see what the key journals and let's see what's the mathematical modeling approach to that. Let's create a simulating environment, let's create a sort of serious game. Then we can talk about change of management. When the business modeling is not is only considered it's only about business, it's a little bit more connected to also to the it's also connected to the previous comment of mine in terms of management. When it's only about business modeling, then we are again a bit far from the fact that this is a project that should include science and engineering. And also when we talk about marketing studies, these are just some examples of projects that were rejected in the past. So it's not only about marketing, it's not only about business, it's not only about management. There should be a clear design, there should be a clear scientific factor and engineering factor where most of the time, if not all the time, mathematical modeling is part of the project for discrete systems or for continuous processes as part of the PPT or PTL tracks. Okay, what's the planning of the project? Everything starts or should start in principle at least 2 or 3 months before you would like actually the project to start. Meaning that you can start looking for projects immediately or just at the end of your first year of the master project. We can have these discussions about the project. We can eventually have these discussions during the first intake meeting, and even when you are taking the course research methodology. It's not a bad idea to talk about proposals. Then I don't see a bad idea doing the design project immediately before the research project, but that's not the norm. We know that for most of the students, the trend is to do the research project first, to gather some knowledge on how to perform research, and then during the last 6 months to do the design project. But actually, it doesn't have to be like that. So you are free to choose what project comes first. And it means also preparation. It means that, for instance, you choose first the research project, and you're very busy with your research project. Maybe you are exactly at the point where most of your key results are just getting there, and then you start thinking about the design project, for instance, in case you choose first the research project. And this should happen in principle, as I said, at least 3 months before everything starts, before your proposal is approved, before you jump into the organization. Now, sending mails to companies, because contacting engineers or potential first supervisors or managers, that requires a set of skills, of course, communication skills. It's for most of the students is an unknown world to go out there and to do it's a sort of job hunting. And indeed, it requires preparation. You need to prepare your curriculum. You need to prepare letters of motivation. You need to know actually what's going. You need to define the topic that you would like that you would like to explore. What sort of topic? What sort of field? What sort of industry? Where would you like to do that? Would you like to stay here in the north? Would you like to go to the west? Would you like to stay in the Netherlands? Actually, would you like to go abroad? Right. So those are common questions, and the design group it has a lot of experience with more than 200 projects now. So we strongly recommend you to send an email to the IEM design project, the email that was at the beginning, to request your intake meeting where we can explore these ideas. The intake meeting, and I'll talk about that in the next slide, but in general, it's about discussing such matters: field, location, area, opportunities, and please don't miss this. Now, let's assume that you start the project. So there are 4 deliverables: the initial problem description, the research and design plan, the midterm report, and the project's report plus your colloquium. Now, this happens in a matter of 5 months after the project proposal is approved. The proposal sometimes actually is approved here in the start, and then you start working immediately after that. It doesn't mean that you can't jump into the organization a couple of weeks or 1 month before everything is approved, just to gather some knowledge more in terms of the problem to be addressed. But remember that if you jump into in an organization in an earlier stage without proposal, it could happen that your proposal can be rejected, completely rejected. And then you need to find probably another problem in the same organization or company, or maybe later on even find a different company. So you need to be careful with that. It's better to have the proposal approved before jumping into the organization here at the very beginning of the project execution. Now, the intake meeting. As I said in the previous slide, the intake meeting is to get to know each other. So This is a first approach, the first way that you will talk to one of the collaborators of the design group, and you will bring your ideas. In principle, you should carefully read the Master Design Project Guide that is in the Nestor tool. You should build a SWOT analysis of yourself, because the guide has a rubric, and there are elements in the rubric that defines whether you are going to get an excellent grading, an excellent grading in most of the deliverables and colloquium, or that you will face a non-satisfactory situation. So then it's important for you to read this rubric that is in the guide, to read the guide, and to bring your questions to the intake meeting. The intake meeting requires preparation. So again, you need to read the guide, you need to explore the rubric, and then you need to create a sort of SWOT analysis. Okay, yes, the SWOT analysis, it's a tool that started, it was very popular in the 70s. From time to time we hear about it, but it's a good idea for you to see these strengths, opportunities, threats that will be part of your and that will actually should be connected to the rubric of the master design project. In the rubric, we have the so-called academic approach. And it's not only about solving a problem, it's a practical problem indeed. We would like you to actually generalize the results. We would like you to embed most of the knowledge that you have acquired during your academical training in the master design project. So this is part of the rubric number 6, the scientific approach. So what did you learn in the project, and how this knowledge can actually be extended, or as I said at the beginning, generalize. For the master design project, the member of the design group, it's actually the first supervisor. Second supervisor is a member of the NTEG staff, or actually, I would say that anyone from the Faculty of Science and Engineering with a doctorate degree, meaning at least a doctorate degree, and connected to the field of design of your project. That can be the second supervisor. It doesn't matter if this second supervisor from NTEG, for instance, was your first supervisor for the research project, or you would like him to be, or you would like her to be the first supervisor of your research project if you choose to do the design project first. And the third member of the panel actually that will be part of the colloquium, is the problem owner, the daily supervisor, the first supervisor in the company or organization. Sometimes the students actually have more than one, and they are also invited to be part of the panel, because those 3 members will discuss your assessment form towards the end of the project. I will come back to that in a second. Coaching is not only about supervision, but it's coaching. So depending on the first supervisor of the design project, you will meet him or her once a week, or sometimes once every 2 weeks, depends on the style of the student, depends on the style of the supervisor. Every time that you will have a deliverable, and to discuss a deliverable, it's a good idea to prepare a presentation, because sometimes in these meetings for the initial problem description, or for the research and design plan, or for the midterm, your second supervisor will be there, second supervisor from the Faculty of Science and Engineering. And it's a good idea for you to control these contact meetings of at least 1 hour 4 times during the project. I mean, this is a recommendation. You are the manager of your project, we recommend to follow these guidelines, but you can always decide that probably every week is too much, or probably 10 slides are not enough. Maybe 1 hour is too much for you to talk about your deliverables. It's up to you. Again, as I said, you are the manager of the project. The idea for us is also for the first supervisors, from the members of the design group, is to visit the company. I mean, this is a part of a presentation that we have done already for 3 different generations, and we really like to go to the company. We like to see the process, we like to see the uncertainty, we like to see the environment. And I know that because of the corona crisis, this last part is going to be probably very difficult to achieve, and we will see what happens in the following months. But in general, the first supervisor, it's in general, it's a good idea for the first supervisor from the design group to visit the company, to visit the organization, and to have a brief discussion over there where actually the student has something new to show, right? Because the student has very good contact, in principle, very good contact with the company supervisor. So the idea is for the student to show something new to everybody. It's not expected from the second supervisor from NTEC to come to the company organization, but sometimes it happens. Sometimes the second supervisor is so engaged that he or she really wants to go and see what is going on with the project. It happens from time. It's about you. It's about the student. Now we have, of course, thinking about the amount of words that you should include in your deliverables. There are some numbers already in the guide: 1,000 words for the proposal, 1,500 words for the initial problem description, and so on. Now, this is the idea right here, is to increase quality instead of quantity. But if you need 20% more words, even sometimes 30% more words, don't take it as a constraint, just try. I mean, this is actually violating the rules that we actually wrote, but the fact that you have this limiting amount of words, that should not be an excuse to not have quality. So if you need just a little bit more of words to express the ideas behind the problem, to express the ideas behind your methodology or the midterm results, I would say feel free to add a little bit more of words. But the idea is to have quality and to express and to communicate your thoughts, results, assumptions, your progress in general. Okay, yes, as I said at the beginning, in one of the slides, there is a rubric. There are 6 elements that are evaluated from excellent to below expectation. And this is important. I mean, that is why we have the intake meeting. We would like you to go to this rubric in the Master Design Project Guide. Just go from the problem analysis, what is expected to be good, excellent, to the research design, academic approach, tools, methods, validation, management, organization, reporting and presentation. So we have thought about these 6x4 elements, and please just read them carefully, bring your questions to the intake meeting, and see, based on your SWOT analysis, what do you need to do, or what do you expect actually from the coach, from the supervisor, to reach this excellent in these 6 elements of the rubric. Just it's an exercise. It's not just text in the guide. Actually, please make use of it and bring your questions. Bring your questions about the rubric. As I said also at the beginning, I'm just repeating myself a little bit too much now. So we have different deliverables. It goes from the proposal that has to be approved by the so-called screening committee, then the initial problem description where you will make use of different tools to analyze the problem, an Ishikawa diagram, a why-what model, a five whys models as a sort of system description based on blocks made with systems dynamics. And after that, you will make use of the information in this initial problem description with the research and design plan, or the midterm report finally comes after the research and design plan, which is just a document that it's independent from the RDP. It's independent. The midterm is independent from the previous one. The midterm actually talks about progress, and finally the project's report. The proposal has 6 different parts. And actually, this talks a lot about the master design project. Please recall that when you are contacting your first supervisor or your daily supervisor in the company and contacting all sorts of stakeholders connected to the problem to be solved, they have lots of desires that not necessarily are real technical requirements. But nonetheless, of course, it's your job to write down about the problem and to gather all this information that comes from Skype meetings, from phone calls, from emails, from official or any other sort of documents or documentation that were sent by the organization or company. Now, it's your job to write down about this problem description and to set up a sort of preliminary problem statement in the first part of the proposal. The complexity should be clear. The key terms should be here defined. And actually, it's the entry point for a very good proposal. So most of the time, the proposals are rejected by the screening committee. Recall that the screening committee meets once a week every Tuesday afternoon to see the proposals that were sent by you via the Nestor tool. So we read them all, we discuss them, I compile the comments, I try to send the feedback the same week, depending on the amount of work. Sometimes when there are so many proposals, it takes more than 1 week. And we know that you are in a hurry. We know that you have already a proposal and most of you really would like to start working in the project. But recall the slide on the timeline of the project. So this is very important for you to start working on the proposal at least 2 or 3 months before actually you would like to start the project. Anyway, so the problem should be clear. It should be there should be complexity. Key terms should be well defined. Now, it's not only the fact that you are going to solve a problem. It's also the fact that there should be some scientific relevance. What is the scientific approach? What is the so-called knowledge gap? I mean, who else out there has addressed a similar problem? So we expect you to bring at least 2, 3, 4 key journal papers that have addressed a similar problem and where the methods that were used and the tools that were used to address such a problem were clear. And this scientific literature actually is quite important. This scientific approach in the second part of the proposal, actually, it's key for us to see that you are working on a relevant field, and that is not only about solving a practical problem, but it's actually trying to extend the body of knowledge, and it should be highly connected to the problem description. Now, and it's not only about the fact that you are addressing a problem, a complex problem. It's not only about the fact that you have really nice journal papers, but it's also about the business case and the business context. What's in there for the organization? Is there a hurry for this? Is there some sort of profitability, saving of resources, return on investment? What are the figures? What are those numbers? You need to be inquisitive and need to request more information about the business impact that will take place if the project is successful, or that is going on nowadays, if because there is no artifact that solves such a problem. Now we strongly recommend you to draw a diagram with key systems or subsystems, well interconnected inputs and outputs, where you can actually mark the scope of your project, and that's in section 4. Please draw a diagram or diagrams if you want to use different levels. It doesn't have to be just one level or 2 levels, 3 level diagram. So it's up to you. But in principle, should be highly connected to the business case, should be connected to the scientific relevance and the problem description. Now, let's assume that you have those 4 first parts of the proposal well described. And in the 5th section of the proposal, we would like to see what are you going to deliver towards the end. Is it an algorithm? Is it a decision toolbox? Is it a simulated environment? What is this output? How complex is this output? What is the nature of this so-called, we call it artifact. Sorry, we call it artifact. It's an algorithm. It's a modified algorithm. Are those the blueprints of the redesign of the process, or the blueprints of the redesign of one of the sections of the process that represented the bottleneck? And it's not only about that. It's not only about showing, okay, this is the algorithm, showing these are the blueprints, but it's also the validation process of this artifact. Did you simulate it? Did you create scenarios? Did you do some sort of sensitivity analysis? What are the statistical tools? What are the assumptions on this pilot experiment? That's why section 5 also is quite relevant for the proposal. And again, this is a storyline highly connected from section 1 to section 5. And sometimes, and it's actually, this is quite important, you can mention it in the problem statement that, let's say, the data that you are going to work with. Are you going to generate your data, or the data is already there to be analyzed in the case, for instance, of artificial intelligence projects where you have hundreds of thousands of data points where you need to filter out and you need to create categorizations, right? So the data is there because the company installed a sensor that has been gathering data, or a set of sensors gathering data for 5 years, but now nobody knows what to do with that data, but eventually they have some insights or hints that actually data could be relevant to predict physical phenomena. Now, so the availability of the data. Are you going to generate the data, or the data is there? What is the physical meaning of this data? So you can always talk about this in any section, from section 1 to section 5. But again, if those sections were not good enough, you can always mention that in section 6 in terms of relevance risk, also states factors for the project. The data and the physical meaning of the data and the availability of the data, please, this has to be well addressed in the proposal. And most of the time a proposal is rejected because there is no reflection on the data that you're going to use or generate. There is no reflection on the artifact. The problem is poorly described. There are no papers. You didn't do your homework. You didn't really find suitable papers. And actually, if that happens, if, for instance, you claim that no, there are no papers that are connected to this project, then you should ask yourself, is this the right project to work with then? If certainly no academic impact is so visible, right? And sometimes the business case is not so clear, but if you are in a sort of organization or industry, I mean, the business case is always there. It's profitability, and they will help you out. There are some units actually specialized in cost analysis of the potential new technologies. Anyways, that can help you out a lot. What else can I say about the proposal? Well, it's one of the first documents, and if it takes you more than 1,000 words to describe all these 6 sections, in principle, the committee doesn't mind if it takes 1,100 words or 1,200 words, right? So, but the idea is that the proposal should be well written. It should have a clear storyline where everything is well connected and justified. And this is actually it took me more time to explain this because this is one of the entry points for the master design project. This is the entry point for the master design project, and you should gather as much information as possible from the very beginning. Okay, let's assume that the proposal is approved. Now I have assigned a first supervisor from the design group based on the availability of the supervisors, based on the topic, sometimes even based on the desires of the student. And this is part, of course, of the work of the coordinator of the master design project. It's a discussion I have with my colleagues to know who is going to be your first supervisor. It takes some time to organize it, taking into account, as I said, the workload also of my colleagues. Anyway, so then after 15 days after you have officially started the project, let's assume that those first 2 weeks, let's assume that you haven't been in the organization at all, that you really need that time to talk with your new colleagues, to your daily supervisor, to gather data, to try to understand those key documents that were given to you now that you have access to actually databases from the company. Now comes an initial analysis, an initial problem description. And in this problem description, we really would like you to make use of tools to analyze the problem, an Ishikawa diagram, or a why-what model, or the 5 whys of the 5 questions, or a system description tool to analyze the inputs, outputs, subsystems, interrelations. How is everything connected? And it's expected to be delivered towards the end of the second week or at the beginning of the third. And okay, so we recommend 15,000 words, 1,500 words, sorry, 1,500 words. And okay, you can, if you really feel like you need more, it's a negotiation process with your daily supervisor, with your first supervisor, sorry, from the RUG. It's negotiation. So talk to him, talk to her. If you feel like you need more space to convey a message, don't be so afraid to discuss it and negotiate it with your first supervisor. Based on my own case, sometimes the initial problem description comes with 16, 17, even sometimes 2,000 words, and I don't mind because then the problem is well described and it's rich and it has enough literature for me to actually explore myself what is going on with the field, what is going on with literature, what is going on in the organization. Immediately after the initial problem description comes the research and design plan. We strongly suggest to make use of the SMART goal, the SMART goal tool that was published by Doran in 1981, where you have a goal that is specific, measurable, adequate, realistic, time-bound. And here we would like to, it's not that you will follow one by one all these bullet points from the presentation or in the guide, but this is a recommendation. In the research plan, you will talk about your problem analysis, problem context, what's the problem statement, right? So what's going on with the stakeholders, what is going on with the system description, what are the inputs, outputs, subsystems, interrelations, from that system, where's the scope? Actually, you can mark the scope of the system. The research design will have the questions highly connected to the goal and sub-questions highly connected also to the sub-goals or to the small goals that will reach the higher goal in your project. And each of these questions or sub-questions should be answered by making use of tools and methods. It's a good idea for you to explain how are you going to answer these questions. I mean, what's in the literature. So everything should be highly motivated by literature. So if you claim that, let's say, MATLAB or Plant Simulator or Aspen or any logic, those are the right, let's say, tools to answer some of your questions. But then you will come to discrete event simulation or continuous process or partial differential equations. Those are going to be your methods. Are you going to use those? Are those the methods, the right methods to proceed? Value stream mapping. There are so many methods out there that you can use. So these methods should be well justified by literature and should be well connected with the questions, and the questions should be also well connected to your goal. So this is a sort of storyline that we are expecting in the RDP. And the RDP, of course, has a go, no go moment. And it's a go that, or it can be a conditional go, or it can be a completely no go, where certainly you can't continue with the project at all. So the project, and then you need to repair. So there are different situations for the RDP, and you need to be careful with that. And it's happening 4 weeks after the project officially starts. Then comes like around 10 weeks after the project has officially started, around 6 weeks after you presented your plan. So there should be some midterm results. It's not that you are going to staple your RDP and then add an extra chapter on literature or an extra chapter on experimental design or so. The idea is to have a self-contained document where you actually talk about a better understanding of the problem so far and results acquired so far, or a preliminary analysis of the situation. Because at this moment, there are only 7 to 8 additional weeks for you to finish the project. So at this moment, you should have now a better idea of the problem and a better idea of your artifact. What are you going to deliver towards the end? The project report actually it's not a compilation of the previous deliverables. It's a self-contained story where everything is presented from the problem that you were addressing towards the methods that you use and materials, and chapters on results, chapters on design, chapters on discussion, chapters on concluding remarks or future work, appendices with let's say code or an extended version of your algorithm or an extended version of your simulation or an extended version of your experiment or results tables. Anyway, so this is a self-contained document. You deliver it once, and of course you should get feedback from your first supervisor. Once this document is in principle ready and approved by the supervisor, so in principle the first supervisor from the design group should send an email to Betsy, our secretary. Once that's ready by mail, then Betsy is going to help you out with the organization of the colloquium. Now the colloquium, of course, it requires some organization. This is also part of your managerial skills. The colloquium will come, as I said, once your project's report it's delivered and approved. Of course, there can be some additional comments coming from the first supervisor, where you can actually improve further your document, a better version of the document. But with the approval of the supervisor of this draft of your project, then you can in principle contact Betsy, and then you try to find a suitable time and a suitable date for the panel to be together and for you to defend. It requires time. It requires a lot of organization. So that's why we have the support of Betsy. But recall, please, that this is your ultimate responsibility. And as I said, it's part of the assessment form. It's part of the rubric. And then the assessment form, of course, it has 4 different elements: design quality. It's in principle, your research project has research quality. Here we are talking about design quality, 50%. Management skills, right? Management skills where you're highly motivated, where you're independent, where you're working as a team, where you're delivering your documents on time, right? So that part is actually quite important. It's 25% of your grading. But also in the design quality, it's about validity. It's about the literature that you have used. It's about the problem analysis, and it's about your concluding remarks, right? So what is the and the quality of your artifact, how you have validated this artifact in the context of the organization, and how academically strong is such an artifact. 50% of your grading comes out of this. So this is why we try to connect, of course, assessment form with the rubric. Those are 2 different documents, but highly interconnected. And of course, in your communication skills, it represents 25% of the grading, which are the colloquium and the project's report. Also important. NDA. So every time that that you are going to work in an organization and the proposal is to be approved, or you're starting to work with the project with the approved proposal, right? So this is a quite important process, and there are 3 main requirements for the non-disclosure agreements on confidentiality terms. Sometimes companies actually have no NDAs at all, no confidentiality confidentiality agreements at all. Sometimes it happens. But I would say that 4 out of 5 the projects are required an NDA. And what we would like you to do is we would like you to be able to share your documentation with your first supervisors. Printed versions, by email, only by Nestor, it doesn't matter. But the documentation should be available to the supervisors of the academy, of the University of Groningen. That's one of the first requirements. The second one is that, of course, you should be able to have a colloquium where the author students are present. Nowadays, of course, virtually present, but the idea is for the colloquium to be announced. The Google Meet link will be part of the colloquium announcement via Nestor, and all at least the IEM student community should be able to be part of your colloquium. Not only you and the panel, but also author students, because we want them to see examples of master design projects. And pretty sure that some of you already have been part of some of the colloquiums. So then the NDA should not limit this. And the third requirement is that you should be able to upload in the repositories of the university a copy of your project's report. Yes, okay. Sometimes companies require that the document should be highly private, which is okay, right? We just need the document there for audit reasons, and where not even the name of the title of the document or the project is even visible for anyone. So that's also possible. It's not an issue, but the document should be there in the repository. So now those are the 3 requirements, and you can read more about this in the section 4.9 of the Master Design Project Guide. Now, if you have a document, a PDF, hopefully, you can always send it to our contact mail. And we will take this document and we will send it to our legal department. They will analyze the document, and if everything is okay, then the director of the master design project is going to sign it. In this case, Minkau. Minkau is the only one allowed to sign NDAs on behalf of the university for the IEM Master Design Program. Sorry, IEM Master Program. So I can't sign these documents. It's nor Betsy, nor Herald Jonker. It's Minkau, the director of the master design of the IEM Master Program. It took me a lot of time to explain this part, but actually it's quite important. Sometimes we have had in the past issues where suddenly there is an NDA, suddenly you can't share documentation, suddenly you can't have a colloquium because the company actually has a lot of restrictions that nobody knew about it only towards the end. So then it's normally I make a comment during the proposals iterations, and normally I keep asking, are there NDAs? Discuss this with your first supervisor. Let's say that they have already an NDA, but the only thing that we will need is just an email from your first supervisor saying that they agree with our conditions and terms, and that then we just print this mail and we attach it to the official document. That's just good enough. But anyway, we should not forget about this. It's quite important indeed, and it's something that most of the time you don't have to deal with in the research project. But okay, so for some projects actually you have to deal with the NDA for the research project, but for the design project, I have to say that the rule is that few times you don't have to deal with this. Well, process engineering, production engineering, and logistics are top nowadays. These were sorry this is data from 2017 2018. 2019 actually, and the beginning of 2020, you will see that actually data modeling is coming to the top. Indeed, I need to update this graph. Together with Python and together with systems engineering, everything is moving to the top. But still, process engineering and production engineering, they are indeed, together with logistics, they are still in the top 5 areas of interest of the master design project. These are just some examples of projects that we have worked in the past. We work a lot with artificial intelligence to solve different problems. We work a lot with food industry. This is an example of manufacturing coconut sugar in Indonesia. And this is an example also, we work a lot with Shell. No, sorry, this is actually for recovering oil. This is one of the competitors of Shell. This is not directly from Shell. And there is a lot of PPT and PTL, meaning that we also deal with serious games or game theory, and this actually is a part of consultancy firms where they want to train better the collaborators, where they want to sell the products or the knowledge in a different way. So you build up an artifact where actually this project was quite interesting. It's completely different, but it still required a lot of programming and simulation. And again, another example is cocoa beans company, famous company in Sandam, and also dimethylator. This was for Shell actually. We have different examples, of course, of proposals, the projects that we have worked with in the past. Companies mostly from the north of the Netherlands, but also we work a lot nowadays. We worked a lot in the west, and more recently we have been working also a lot with Resato, Philips. With Philips, we have always 2 or 3 students in parallel. Bell Simple here in Groningen in the city. I really like to work with IEM master students. because you bring new insights into the organization and the company is expanding. Picnic has expanded a lot during the 5 years, and IEM has been part of this expansion. Fokker actually also in here in the north also represents has a rich amount of projects, mostly connected to improving the production processes in parts for the Apache helicopter, parts for the Airbus wings. Anyway, so those are very exciting projects and more. So also, but we also have projects outside the Netherlands. Normally in Indonesia, Malaysia, sometimes in South Africa, more recently in Canada. It's not, of course, a restriction. We encourage you to stay in the Netherlands and to do the project here in the Netherlands, because there are a lot of problems to be solved and very interesting companies to be part of. But indeed, if you if you have this decision that you really want to go abroad, and for the Corona crisis, I don't know if that's going to happen in the following year, but anyway, so if you decide to go abroad and you do your project abroad, if you really want to have that experience, well, you need to prepare a very good proposal. Actually, you need to prepare a very good proposal most of the time, but the proposal abroad, from a project abroad, I have to be honest, it's more difficult to be approved. We have issues, of course, with visiting companies. We can't visit a company abroad. There is always this uncertainty with the long distance projects. But anyway, so those are just restrictions. Still, if you really want to do the project abroad, you can do it abroad. So we will help you out over there. And these graphs, I will show this one from 2016, this graph also from 2017, 2018, and we have the same trending from 2019, and now we almost have the same values for 2020. The idea here is that there are two peaks for proposals. Normally the trending is that in February, March, April, we have lots of proposals to screen. And so it means that our response time in the screening committee is slower than normal. And it happens also again in September, October. And of course, that's connected to the fact that some students are here finalizing their research project in February, March, and just starting to look for projects for your design project, because then that batch of students would like to finish the design project by July, August. But then, of course, we have a second wave. We can call it wave. A second wave, second peak of the wave is here in September, October. We would like really to have a more distributed, at least in two different waves, half of them in February, March, and half of them in September, October. But this is based on your decision. When will you like to start your design project? That decision, that question. And thank you so much. If you remember that if you have questions about this, just please send me an email to the IEM design project at rug.nl, and I will do my best to answer your question as soon as possible. Thank you so much. Again, my name is Mauricio Muñoz, and success with the second year of your IEM master program. Thank you.